All right. This video is more of what we did last time. Actually, the notes for today, even though your paper is stapled together, it's going to be in two videos, so the videos don't get too long. If you need to pause a little bit in between for a small break, you can. All right, so these problems, this is what we started with when we learned trig, is not solving, just setting up the ratios. And standardized tests really like to give these questions on no calculator portion. So it's really important you just know how the equation's set up. And so we're going to leave our answer as simplified fractions. But to be able to do this, we need to know what the missing side is in this triangle. We need to know the top side over here. So to do that, we need to do Pythagorean theorem. So I'm going to take the square root of 3 squared plus my missing side, x squared, equals the square root of 7 squared. When we square a radical, it cancels, so I get 3 plus x squared equals 7. Subtract 3 from both sides, so I have x squared equals 4. Take the square root, so the missing side is 2. Then if I read closely, it says it wants me to find the sine of A, cosine of A, and tangent of A. So looking at angle A, I'm going to label my sides. 2 is opposite because it's not touching. Square root of 3 is adjacent because it's touching, but it's not the hypotenuse. And the square root of 7 is the hypotenuse. Now, one more thing before we write the ratios, I think for a lot of you, it would be helpful to write our phrase SOHCAHTOA on the top of your page so you can have it as a reference. So the first thing they want is the sine of A. So sine is OH, opposite over hypotenuse. So the opposite side is 2, and the hypotenuse is the square root of 7. That answer is correct, but we can't leave it like that because of the radical. So we're going to multiply top and bottom by the square root of 7. So that gives me 2 square root 7 over 7. Cosine is AH, adjacent over hypotenuse. So the adjacent is the square root of 3, and the hypotenuse is the square root of 7. So to simplify, I'm going to multiply top and bottom by the square root of 7. So that gives me the square root of 21 over 7. Last but not least, tangent is OA, opposite over adjacent. So it's going to be 2 over the square root of 3. Need to rationalize the denominator, so I get 2 square root 3 over 3. And right here, these are my final answers. All right, we're going to do this again, but now we've got a 30, 60, 90. And when I give you either a 30, 60, 90 or a 45, 45, 90, I will not be giving you the side lengths. It's going to be up to you to fill them in. But because 30, 60, 90, and 45, 45, 90 follow a pattern, it's the same pattern every time. So you can pick whatever numbers you want, but the most efficient numbers to pick would be the shortest side being 1. And if the shortest side is being 1, to get the medium side, we have to multiply by radical 3 to get the medium side. And then we have to go back to that short side and double it to get 2 for the long side. Now that we have the numbers on it, now we need to see which ones they want. And this one, it looks like they want 30. So if I look at the 30-degree angle, 1 is opposite because it's not touching. Square root of 3 is adjacent, and 2 is hypotenuse. So to get my trig function for sine of 30, it'd be opposite 1, hypotenuse 2. But I don't have to simplify that anymore because I don't have a radical in the denominator, so I could just stop. Cosine would be the adjacent over hypotenuse, so square root of 3 over 2. But again, we're good. And then tangent is opposite over adjacent, 1 over the square root of 3. We can't leave our answer like that, so we'll multiply by the square root of 3, so we get the square root of 3 over 3. And we're done. Okay, these next problems we're actually going to start solving. I'm going to recopy the phrase, but you've got it on your paper, so it's no big deal. Okay. When we start solving, we can do one of two things. We can find a side length, which is what x is here, or an angle measure. So for the side length, we'll set it up like this. So we're going to start by circling the angle we were given and then label the two sides. X is the adjacent side and 14 is the hypotenuse. And the trig function that uses adjacent and hypotenuse is the cosine. So I'm going to say the cosine of the angle measure I circled, that's 31, equals adjacent over hypotenuse. That's x over 14. Now this time when I wrote my equation, x was in the top. And when x is in the top, I multiply. So what I'm going to be putting in my calculator is 14 times the cosine of 31. So if I grab my calculator, Make sure the first thing I want to do is hit the mode button, and I want the word degree to be highlighted. If radian is highlighted, you need to scroll down using your arrow keys, put your cursor on degree and press enter, but you want degree highlighted. If degree is highlighted, then you know you're in the right mode and the problem will work. All right, so now we have to 14 times the cosine of 31. So when I type that in, always put the number before the trig function. Otherwise, you'll have some logistical issues. So 14 times the cosine of 31. Now on side lengths, we're going to round to the nearest hundredth. But on the nearest hundredth, that's 2 decimal places, and this time they're both 0. So technically, the 2 zeros go there. But if you were to ever have a problem like this again, which is not very likely, will it be 2 zeros, I would take 12, but let's just try and put the 2 numbers after the decimal. Let's try this again on number 4. So if I circle the angle measure I was given, label the 2 sides, this is opposite and adjacent. So the one that uses O and A is tangent. So I write the tangent of what I circled, 63, OA, opposite over adjacent, so it's 11 over x. Now this time, x is in the denominator. When x is in the denominator, we're going to divide. So in our calculator, we're going to do 11 divided by the tangent of 63. Always do the number first and the trig function second. So when I put that in my calculator, I'm going to do 11 divided by the cosine of 63. Oh, except this was the tangent. I apologize. Let's try that again. 11 divided by the tangent of 63. It's my fault. Short-term memory. Okay. So I get, oh, now I forgot the answer. Holy moly, 5.60. I apologize. 5.60. All right, so on those first two, they wanted side lengths, but on the next two, they want angle measures. So look how there's a lot of similarities, but we'll put in our calculator slightly different. So you're going to start by circling the angle they gave you information about, label the 2 sides you know. So 11 is adjacent because it's touching the angle. 15 is hypotenuse, and the trig function that uses adjacent and hypotenuse is cosine. So I'm going to take cosine of what I'd circled, x, equals adjacent over hypotenuse, 11 over 15. When I'm solving for the angle measure, like over here, I knew the angle measure. I was solving for a side, but when I'm solving for an angle measure, then I'm going to say x equals the inverse cosine of 11 over 15. So in our calculator, when we put that in, we are going to do to get the inverse cosine that's in blue. So second cosine 11 over 15 and hit enter, we get 42.83. Now for angles, we round to the nearest whole degree. So to the nearest whole degree, that would be 43 degrees. So this one is 43 degrees. All right, last one for this video, and then the notes will continue in the second video. But we're going to look at this angle measure here that we are given, label the 2 sides that have information. 12 is opposite, 23 is hypotenuse. So that would be our sine function. So we have the sine of x. Sine is OH, opposite over hypotenuse. So we have 12 over 23. And if we're finding the angle measure, we're going to do the inverse sine of 12 over 23. So in our calculator, if we do second inverse to get the inverse sine of 12 divided by 23, then we get to the nearest whole degree. It doesn't round up because 4 is less than 5, so it's going to be 31 degrees. All right, so this video is done, and now you can start the rest of the notes that were copied for you with the second video.